Welcome to all of you, and thank you so much for being here. By the way, for the audience, as I mentioned before, we asked for audience questions. That's why I'm holding an iPad. So we'll see what hard questions you have for our panelists. But let's kick off with just some intros. So joining us, we have Chris Lattner, who is the CEO of Modular, and you almost certainly also know him as the co-founder of LLVM and Swift in previous lives. Chip Huyen, who's like the best-selling author of designing machine learning systems and currently at Voltron, and Michael Suo, who is the technical lead for large-scale training at Meta within the PyTorch team. And rather than doing kind of bios and everything, I thought it would be fun to just ask all of you, and I guess we'll start with Chris. Can you share just a little bit about kind of your personal journey that got you into AI? Obviously, you started out in compilers, moved into AI. What
Sure.
was that about?
For me, it was really about, so I was leading the developer tools team at Apple with Xcode and Swift and Clang and all this stuff. And I just could not figure out how photos could understand what was a cat versus a dog. And this was 2016 kind of time frame. And when you're in charge of like helping people build and solve problems and build apps that can do things, it's like, how does this work? And so I fell down the rabbit hole of saying, well, I don't know how to write for loops to tell if something's a cat versus a dog. And so for me, that's where it all started. And from there, went straight through applied applications and self-driving cars, the infra side, scaling Google TPUs, a lot of embedded stuff, weird chips, a lot of the hardware-software boundary, which is where I naturally gravitate towards. But it was really that, cats versus dogs.
That's awesome. Chip, I guess I have the same question for you.
So I have like the good answer and the real answer. So the good answer is like, oh, AI can like get rid of the language barrier and then we can communicate and the world is wonderful. But the reality is that I just got into AI because I didn't want to deal with segfault. So I was taking some database classes and it was like really painful. And then there was these AI classes where you can just write like algorithm to play games like Pac-Man. It was like, yes, that's a lot more fun.
That's awesome. Michael?
I started off my career in sort of distributed systems and data stores. So like many segfaults later, I was like wondering what to do with my life because I also did not really want to deal with that. And I think for me, I think AI was interesting because I saw like a lot of the problems that we have today have to do with how much information is out there and how can we make sense of this? And it's pretty clear now that like as people, we can no longer make sense of this information, but we need sort of tools to help us do this. And at the time that I joined, we didn't really have, the transformer. We didn't really have anything like that, but we had sort of the early sense of, there's cats and dogs in these videos, right? We had like LSTMs, the kind of like early inklings of what we have now. And it was really clear what the potential was. So I just kind of picked up, I joined the PyTorch team and haven't really looked back.
That's awesome. So we had a bunch of great questions from the audience. And let's start off with maybe one of the hardest questions in here, and I guess I'll mostly direct it to Chip, but I'm curious to hear thoughts from like all of our panelists here. So someone asked, what are your thoughts on models getting to AGI, and more specifically, what is the threshold? Like we all talk about AGI as being kind of a goal that we're pursuing. What does that mean? Like, what's the threshold for us getting to AGI?
So just before this, we had a rock, paper, scissors, and I lost, so I got the AGI questions. So it really depends on how we define AGI. So whether it's like average, general intelligence, or it's like absolutely godlike intelligence. So I think like it's just like generally average intelligence, I think we are there. I feel like for a lot of tasks, I much prefer like working with AI than with the average person, like working on this task. And for the godlike intelligence, I think that I'm not sure we wouldn't ever get there. Because I'm not sure I have the experience, but like for whatever task I use AI for, it's usually really, really good. It's like 99% of the way there. But then just something really small and you cannot get it to like do right. So I'm not sure we will ever get there, or we just have like this like pretty good AI that can do like get us like 90 or 99% of the way there, and then we have to build like other tools around it to make it work.
You don't think that a data center the size of a city will solve the godlike AI problem?
I mean, I really like that framing, right? I think when we talk about AGI, it's almost like a religious question, godlike, right? Because I think we don't really have a coherent understanding of how to measure intelligence, what do we consider to be intelligent. So I think like task-based approaches, right? Like, would I use an AI rather than a person for this class of tasks, given that the latency or whatever of the AI is likely to be much better? And I agree that like for a lot of things, we're kind of there. And the generality of it, I think, is really hard because, it just eludes definition, kind of, right? Like you like work out on all these different tasks, and then somebody poses a new task. Is it really important that our AI be like fully general? I don't know. I don't think people are fully general either. So I think it's more important to talk about sort of like usefulness on specific tasks that we care a lot about.
I guess that actually dovetails into another audience question, which was around really like scaling laws. And right now we're seeing kind of this huge like exponential increase in kind of the amount of like data, power, everything that goes into training these models. What do you all see as the trends going there? And maybe I'll pick on, since I picked on Chip for the first one, I'll pick on Chris for this one.
Well, so I think scaling is massive. It's both in terms of the training side, which is what people would naturally think about when you're asking the question, but it's also in consumption, right? I mean, as you look at what Gen AI has done, it's actually entered the public consciousness. It's actually starting to solve problems for people. And what that means is the inference side of things ends up maybe not being the only thing, but it's massively scaling. At the same time, what you have is you have a scaling, which people generally don't talk about, which is a talent scaling problem. How do you get more people to build AI and Gen AI and all the different things in the space into their products? And that becomes an accessibility question that I think there's a massive unlock potential for just making it more, so it's not just the biggest companies in the world that can do this, but it's so that average developers, whatever that means, can actually build these things in their applications. And I think that when you start looking at this, it's hardware scaling. Maybe not one vendor is the only one that builds all the chips. Maybe we should have multiple vendors, right? And how do we get communities of people that can scale across the different levels of abstraction needed to build these massively complicated stacks that are doing amazing things? So to me, I look at it scaling both in terms of flops, yes. I think that will also scale, but it's also about things like how do we build products, right? And I think that's the real unlock that we're all seeing and looking for.
And what do you think of the bottlenecks there? And I think one of the other questions by way from the audience that I was going to ask all of you was, how does someone who is not currently like specialized in AI get into the field? Because that feels like one of the big bottlenecks that we're facing.
Well, so I mean, I don't know how spicy of a take you want, Damien.
As spicy as possible.
Well, so PyTorch is brilliant because if you go back to 2017 when PyTorch was rising and TensorFlow was faltering and like this whole thing, back in the day, the old timers would say that we're on a quest to democratize AI. Right? I don't know if you've heard that for a number of years, right? We've kind of forgotten that. Well, PyTorch democratized AI. Success, right? And now roughly every computer science student graduating from college knows how to train a model thanks to PyTorch. On the other hand, PyTorch didn't democratize deployment. And so model deployment is one of these problems. It's just really, it's a dark art. Like speakers today were talking about how hard this really is, and this is very undemocratized. And so to me, I think that it's very much about software, it's about systems, it's about the fact that there's so much complexity at every level of the stack that, it got created and hill climbed and changed, and none of these systems were built for Gen AI. We need a reset. And this is what we're working on at Modular, of course, but this is a really huge opportunity, but it's really hard, right? You need to actually be able to do the fundamental work, and you need to not be on a 6-month, I have to go deliver impact in a short window. You need to be able to do these really deep, fundamental, hard tech problems like solve compilers and programming languages and GPU coding and like all these things, which are all really, I think, mature concepts, but the reality of them is still a hot mess. And it's a gigantic disaster, depending on how you want to lean into that.
Yeah, I mean, I totally agree. I mean, on the question of how would someone, with a background in computer science, who's a software engineer, but doesn't know that much about AI, I think that was kind of like me in 2016, 2017. I joined, I was like, man, I feel like I'm too late for this, right? Like, we've already figured out how to do sort of image classification. We've already kind of, the sort of framework side of things had been firming up. And turned out, no, like there's so much runway left, and there's so much innovation, there's so much potential for improvement, because honestly, we're at the very beginning. Like the maturity level of these stacks for the kinds of things we're asking them to do is almost non-existent. We're like inventing things as we go along, and a lot of the problems are problems from other domains in computer science, right? There's compiler problems, there's just like, production management problems, there's hardware problems. And so I think that, if somebody was looking at, how do I get into AI right now? I think it's just find the place that you're passionate about. Find where you can add value to this stack. I mean, it's totally, like, it's completely, from programming language all the way down to the hardware, completely open, because it's stuff that we're all just trying to figure out. And I think, there's never been a better time in terms of like the materials available. Like Andre keeps putting up a new YouTube video every week, and like it's really like, part of the openness of the ecosystem makes it really easy to learn and get familiar with, which is awesome.
Just to plus one you really quickly, hilarious. In 2017, I thought I was too late.
Yeah.
I thought all the best work had been done.
Chip, I know you've actually taught this at Stanford, so I'd love to hear your take on it.
So I do agree with both Chris and Michael that like productions is actually like the way to go right now. So I feel like I do think that's like if I were an educator, I think that's like an absolutely required assignment for everyone is to go out on the weekend and just try to make note of like how many of the people they interact with wouldn't be replaced by AI. So like, I will go to a fast food restaurant, so go to like a DMV, and I see like, okay, when is this person be replaced by AI? Okay. People told me that I should not bring this up in public because that's not a nice thing to say. But I do think it's like, I just like tried it, and I think it's like a lot of things just so painful. And you can just like totally see that like, why are people not using AI for this? Like, why are we still like making companies paying, like making customers suffering through all of this? Why it could be like, I don't know, like 5 minutes like through AI. So for example, like call center. Actually, I'm not sure if people saw this recent very popular Reddit thread. It's about like someone who worked at a call center, and like as soon as that person saw a demo, he was like, I'm looking for a job. Like it's just like, you see like there's so many people working in call centers today, and it's just, I think it's a prime example of like things it's like we can still need a lot of GPUs for. But also like there are other stuff. So I was like doing this like text to speech, and even though it's like pretty good, and we have like many new voices coming out, but it's also that I feel like, why are we still not using those in daily life? So maybe there's a lot of like kinks, like quirks. For example, I was using text-to-speech from Google. I tested out like Google 11 Labs. I tried to use OpenAI, but somehow they got rid of all their voices. Like they don't have a text-to-speech API anymore. And I don't understand why, because they have really, really strong voices. But like, they're very good. But then they do something dumb, like if you say like, hey, the character pauses. So like if you were a human doing narrator, right, you could pause and then continue. But the AI is like pause, continue. Or like it can't say the initial, like it's like IMO, it was like emo. Like it's a lot of small things like this. It's like very painful, and I feel like a lot were trying to build like really big models to make better text to speech, but I just want somebody to let me do like something like audio surgery. Like it's like, okay, here's the audio, I just want you to correct this one word. Like I just want to do it. I don't want a whole new model. I just want it to be better at one specific thing.
That's awesome. Thank you. I'm looking at the time. I think we have time for like maybe a couple of questions, and I'll kind of address those to all of our panelists. But let's start off with, someone was asking, kind of, we've all heard about acquiring, powering, and dealing with GPUs as kind of one of the bottlenecks that we all have right now in AI. What do you see as the next challenges and bottlenecks in infrastructure for either training or inference? You can.
I think that it's really funny. Like one of the advantages of being in the industry for decades now is that you get to see trends and you get to see cycles, and you start to realize that if you zoom out, today everybody's talking about Hopper, stock out, availability, and how big of a cluster you can make and things like this. But zoom out and look out 5 years. Right, so get out of exactly what letter comes before 100 or something. What I believe is that there will be a lot of hardware because everybody's making their own chips. What I believe is that there's going to be a lot of personalization, like a lot of wearables and other things, a lot of IoT, a lot of other places where AI will pervade our lives in all kinds of products. What I believe is there's going to be a lot of software developers that want to be able to deploy and build applications for these systems. And so I think that the grand challenge is like getting it so that we can close the gap between the software community and the hardware community. Because right now, people building chips, this software thing is a very amorphous, very difficult to access concept, and AI is moving so fast, which is one of the most beautiful things about it. On the other hand, you get to a lot of the application level people, and they really don't want to know about the silicon. They need it, but they want to think about the algorithms, right? And so I think this is a grand challenge. And so I think that as we scale into this, I think one of the great opportunities for us all is to innovate at every single level of the stack. Like I'm sure that there'll be, maybe SSMs will rise or something, and the transformer will have a new tweak that will totally change the trajectory of everything, and some new KV cache optimization of the day will amazingly transform how we think about things. But it's really, again, this tribe. Like, how do we get people talking to each other? How do we break down the boundaries? How do we enable this innovation to flow more freely? And I think that's really the macro challenge when you look across years of development, because nobody wants it to slow down. I mean, I shouldn't say that. Some people, I'm sure, do. I don't want it to slow down. I think that it can go even faster. And so I think that's what the way I look at the world.
Yeah, I think in terms of bottlenecks, unless do you want to do another question?
We got a couple of minutes. Go for it.
I think, in terms of training, I think in addition to GPUs, I think the other big thing is, right, like the availability of training data. I'm looking at our data infra folks. I think our hunger for new, different, varying data sets, like clean data sets that have been vetted in various ways, like legally or policy-wise, I think it is only increasing, and we're having, I think across the industry, a lot of trouble getting good, high-quality, clean data. There's the whole debate about synthetic data and what that might look like. And so I think, luckily the industry and, our field in general has a lot of experience with sort of very, very large-scale data management. But I think sourcing that data is going to be a big problem. And I think, starting from the beginning, right, like should we be putting more like sensors out into the world so that we can get good sequence data for some of these things is the sort of stuff we're going to start looking at, right? How can we get just really high quality data from not just what's already there on the internet, but like actually going out and collecting more is kind of an interesting thing that I expect to see in the next few years.
Yeah, so I think it's like, I would think that like, data, I think it's like another electricity. I think we're consuming data centers like 2%, 1 or 2% of the world electricity, so we have like a 50 times more to go, which is like not even like 2 orders of magnitude. So another thing is regulations, make it easier for people to like use AI.
Actually, it kind of dovetails fairly well into the last question. We only have a couple of minutes, but I guess Chip, I'll point that one at you as well. So someone was asking, we've talked a lot about open innovation and openness today. And the question was, I guess it's almost something I should be answering, but I will put it back to the panel, which is like, why is Meta like investing so much in PyTorch and open source technology? But I guess like, Chip, from your perspective, like how do you see the value of building this, in the open and open source as opposed to kind of more proprietary solutions?
I'm very cynical about this. So I think like open source has a lot of values, but the question like who do they have values for? So of course for users, it's for the third-party AI providers, right? Like they can take an open source model and commercialize it and make money. But I was like, let's say that like, say you have the best possible model in the world. Would you put it out for free? Or would you like make money off it? Right, so I feel like yes, maybe right now Meta is doing it because like Meta is trying to catch up to this whole race of like AI. But the question is like once they get there, will they continue making it open source?
I don't think Damien's allowed to answer that question.
I'm not going to directly respond to that, but I think I'll just say we're pretty committed to this. But time will tell, right? But it's a very fair question, right? But
and
Michael,
on the sort of subject of like setting aside the models themselves, but just like our investment in PyTorch, for example. I think a big part of it is, as we talked about, I think openness is really important because if Meta were to close off and sort of focus on our own infrastructure, our own software, you're essentially saying we're betting on us versus the entire world in terms of innovation. And for PyTorch, we have a position where we have a really strong ecosystem. Like all these new techniques, anything new is either originally the reference implementation is in PyTorch, or you wait a few hours, someone will put up a repo in PyTorch. And I think that's like a really powerful concept. Like we can all, if we make PyTorch better, it kind of accelerates things overall, and we can,
Force multiplier.
Right? Sorry?
It's the force multiplier.
Yeah, the force multiplier. And then we can bring it back to and improve our products pretty rapidly, because we're like, okay, we use PyTorch, it's pretty easy to incorporate and build on top of what the community has and contribute back. So I think, from that perspective, if you have something with such a large force multiplier, it's like, how could you not invest? And luckily, our leadership, Damien, and all the way up to the top, they like pretty internalize the value of that sort of thing. So I think that's why we continue to invest.
I would also zoom out. PyTorch is amazing, obviously. I think that that's clear. The work on the llama models is profound, right? Because I think that one of the things that we as an industry struggle with, and I don't think that all the answers are there, but one of the answers we have are, will the models be proprietary and locked up? And one of the things I think is really challenging when you're talking about building these things into a business is the fact that if you're using some endpoint solution with either a proprietary or an open source model, it's really hard to build on top of that when you don't know if it's ever going to change. And so a lot of, I think, the Llama work and many other researchers across the internet and things like this, and the open collaborative nature of AI, I think, is enabling a lot of people to build products with AI at their core. And I think that that openness, the transparency, the sharing of the models, which I don't think that Meta has to do, and I hope that it continues, and who knows, Chip, I understand the skepticism, but for as long as that happens, it's an amazing thing, because it's really catalyzing tons of innovation in lots of different ways. And I think a lot of people that I talk to on the business side of things, when they're building into this Gen AI thing, the natural thing to do is to reach for some well-known company's endpoint, but then the problem is that their evals drop. Like on a Thursday, and I have no idea what's going on, right? And it's like, wow, that's really bad. Or I have to send all of my traffic across the open internet to this endpoint, or I need to send this company my data so they can fine-tune their model on my data, right? And I think that this is things where what Llama and what open technologies allow to happen is we get to kind of fix some of those problems, and we get the flywheel going. And does it go forever? I don't know. Fair point, and I hope so. But I think that's really powerful. And so I think that a lot of the power and a lot of the progress in AI, even back in the days of TensorFlow or whatever, have really been made possible by the sharing. And I think it's amazing.
I just want to correct myself. I feel I shouldn't have said that at the Meta event. I think this Llama model is incredible. I think this I think PyTorch is incredible. So I'm really glad that Meta is one of the few companies just investing a lot of money. It's not cheap to build something like Llama 3. So you're actually investing money, and you actually really have really good people. And I was asking a lot of my PhD friends which labs you want to work with, and Meta AI lab is always the top 3. So I think, but it's really incredible. So I just want to say that.
Yeah.
I can attest to building this stuff is very expensive.
On that note, I think we're slightly over time, so I'd like to thank our panelists for joining me today, and thank you very much.